record in this. Okay.
Okay, thanks a lot, Tijk. I will start by sharing my screen and first give a small presentation. So yes, welcome everybody to today's workshop. I will be talking about the R package datatable, which is all about fast data handling and concise syntax in R. As a disclaimer, I'm not a developer or anything. I'm just, I started using this package from about the start of my PhD, and I think it has helped me a lot. So I'm excited to share it with you. It's a quick outline of what we'll do today. I will start with this presentation for about 20 minutes, which is about all like what is datatable and why should you use it. And there is a short time for questions before we can go into the scripts. We will do a walkthrough of it, which will hopefully give you some background to fall back on. You can use it sort of as a cheat sheet when you try to use datatable yourself. And then at the end, you can, of course, ask questions. And I also prepared a few exercises that you can practice datatable with. So what is a datatable? It's an R package developed mainly by Matt Dowell. And it has been around for quite a long time already. Its first release was in 2006. But all this time and still it's really under active development. Within R, it functions as an extension of data.frame. So you will have your regular R data frame, which will then also be an R data table. And the focus of this package is really on fast data handling. So it has been really the main focus of this package. And with data handling, some people call it data wrangling. We mean reading, writing, selecting certain rows, joining together multiple tables, these kind of things. The fast data handling is really its main selling point, I would say, but it also offers a very consistent and concise syntax, which is sort of as big of an advantage, at least in my opinion. So why do I give this workshop? Well, the first reason I haven't put on here, but it's sort of my favorite R package, and I like to talk about it. And instead of bothering people that just want to have lunch, I might as well give a workshop and get maybe some people that are really interested in it. But also, I think it's one of the more often used packages in R. A lot of other packages depend on it, but it isn't advertised that often. So a lot of people do not really know about it. And I think it's good that some people that you're aware about the options that you have. This is why I think it's good to give this workshop. Second point, it has helped me a lot to write more clear code and faster scripts. So I hope it can help you as well. But lastly, and most importantly, this Limnoseries is part of the Gleon community. And I think fast data handling is especially important for this community, as one of the keystones of Gleon is high frequency data. Long-term data sets, which means that we have a lot of data to work with, which means that fast data handling is especially important. Modeling is a large aspect of Gleon, which can generate also a lot of data. And of course, the G in Gleon stands for global. We do a lot of global analyses, which on top of that makes the need for fast scripts higher than in maybe other fields of limnology. So about the performance of datatable. Firstly, it's often said that R is a slow language, and that's true. When you look at the speed of, for example, for loops, there are languages that can do this faster. But one of the main advantages of R, I would say, is the use of that it's very accessible. Like in data frame, you can put headers, you can combine different types of you can combine numerics, you can combine characters, lists are another example. So it brings it a bit closer to the user. And when it comes to so a data frame is in that sense maybe more accessible than, for example, a matrix. And when it comes to speed, it's also important to realize when is this important. So if you have a single use script, I mean, you will never run script only once because you'll probably do it wrong and you have to do it again, but it's intended for sort of a one-time use. Then if you have a small data set, speed is really not that important. But if you have a very large data set, then it can actually become important. And what is big and small, I guess it's a bit arbitrary. It depends on the power of your computer as well. I put in the top right something like some file sizes to give some indication. This is from a data set that I used, which has 13 years of water temperature data in text format and 12 distinct depths. So when it's an hourly, it's 11 megabytes, which is, I guess on the top side of what we might still call small, or it's intermediate. But when you go to 10 minutes or even 2-minute frequency, which is what the original data was in, then you would get into what I would already call quite a big data set. And it was really working on this data set that also motivated me of trying to find some faster solutions to speed up my workflow. And of course, these are for single use events. If you do repeated analyses, then even small improvements in performance might even save you hours potentially. So this is a part from a presentation by Jan Gorecki. These are some packages that were released over the years to improve data handling. And in blue, we see the R packages, which is here datatable in 2006 and dplyr in 2014. Of course, in base R, you can also already do it. So that was even before this. And then pandas is a very well-known Python package that a lot of you might know. And then the last years, there have been new software coming up. So datatable is a bit on the back end, you might think. But then if we look at some benchmarks of how well datatable performs, this is a website. You see the link that's almost real-time checks performance of different options. So this is a group by, these are multiple group by tasks on a data set of 5 gigabytes. And you see the datatable is actually the fastest if you compare to several other softwares packages, and especially compared to probably the most popular alternatives, pandas and dplyr. It is really a lot faster. Multiple factors faster even, you could say. So if this would be a join operation for a smaller data set, now some packages are faster than datatable, but still in terms of order of magnitude, these are still relatively similar and much faster than once again, dplyr, pandas. And the advantage of datatable often increases the bigger your data gets. So if this is 50 gigabytes, which is a humongous amount of data, I cannot really imagine working with it, but if you would, then datatable would be an even better option. I should say I made these slides in March. I checked recently, it seemed that the Polars package, which is made in Python, has received some upgrades and is now slightly faster in several of these tests, but still the overall order of packages is still the same. And it really leads to the conclusion that if you want to work with these data frame-like objects, R is really not slow at all, but then you should be using datatable. So why is it so fast? Well, the main overarching reason of that is that speed has been the main focus of the whole development process. So that's 15 years of development, trying to make a package as fast as possible. If you look at the GitHub code, you see that it's there is more C++ code than R code in there. C is a very fast language. The internal structure of datatable makes more efficient use of memory, making it faster. There is less in-memory copying if you make a copy of, or if you create a new column, for example, there is less in-memory hard copying. By the way, I am using memory efficiency and speed as a bit of the same thing, but sometimes you could run into memory errors. I don't know if some of you already had these errors in RStudio. That's something that actually datatable also helps to mitigate a bit. And there is some low-level multi-threading, which means that you use multiple cores when reading or writing data, for example. But what I really like about datatable is that most of this will happen internally. So you can write your own code in C++, but you have to do a lot of effort. It's a different language. You have to initialize all kinds of things. But if you use datatable, you can sort of code normally and still get a high efficiency. But as I said, speed is not the only advantage that datatable offers. Datatable has a different syntax than base R. And yeah, I found this quote on the internet, which I can really apply to myself as well, which is come for the performance, stay for the syntax. And that sort of happened to me as well. I started using datatable to make these huge data sets a bit easier to handle. But now I also use it for tables with 10 rows, for example, because I really like the syntax. Its main trait is that it's very concise. So you type less, you write less. And it's very consistent. So there's always the same order of operations, essentially, which can be summarized as you can see here, I, J, by. I is what rows do you want to do something. J is what do you want to do, and by is by what groups. We will work more on this in the walkthrough, of course. Well, when we're talking about syntax in R, I think thaidiverse is a topic that we kind of have to touch upon, which is also a very popular alternative syntax to base R. They follow a bit different strategy. Thaidiverse tends to be more verbose, so you type more. But they have, for example, verbs as function names, so that it's maybe more clear what the function does. And they use pipes, so you can read your code a bit more from left to the right, as you would do with a normal language. And datatable is more alike query languages, such as SQL. That's not to say that you have to know SQL. I don't know SQL either, but it's just a different strategy to maybe the same goal. And something I would add is that it's somewhat closer to base R than thaidiverse is, but you can fill in if that's good or bad. With these kind of things, I don't think there you can really say which one is better. That really comes down to preference. But you should know that if you want to use datatable, you should use some of this syntax to get this better performance. So that might be a downside for you if you like thaidiverse syntax. However, there is also the dtplyr package, which lets you sort of write in dplyr code, and then it's translated to datatable, and then it's run. So it's not quite as fast as datatable because it has to do this translation, but it might be actually the best from both worlds for you. So yeah, check that out. I will not use it in the walkthrough, but it might be something that you can use. So as a very quick comparison of the thaidiverse and datatable syntax, the code on the left and the right do essentially the same thing. These examples come from a Stack Overflow discussion where it was actually nice to read. Like the main developers of both packages sort of made very long examples of how to essentially why their package was better. So yeah, you can see on the right, datatable is very short. But this was the example given by the datatable developer, Hadley Wickham, the developer of the main developer of thaidiverse, gave this example in which you can probably see that there are also a lot of parallels between the two. So you can see there is, there are a lot of parallels, but also some differences. And I mean, it's not either or. You can also combine the two if you would like that. So I wanted to end the presentation by giving a short flow chart of whether you should use datatable. If fast data processing is important for you, then definitely datatable might be nice for you to use. If it's not, but you do like the syntax, then also I think datatable might be interesting. If it's neither, then I should say that datatable is probably not that useful for you because it's a bit like dplyr. It does not give you extra tools to do something. It offers you a different way, and in datatable's case, a faster way of doing the same thing that you could do with base R. But that being said, I hope that there are at least some people at least willing to give it a shot. So I will work with that. So yeah, to summarize, datatable is very fast on especially large data sets, significantly faster than even some other software. But yeah, it's easy to go overboard with trying to make your scripts faster. If your file size is not big enough, it will likely not matter. But there's also the consistent and concise syntax that you could use, which we will learn to work with in the walkthrough. So with that, I would go to the hands-on part. I guess this would also be a good time if you already have some questions that you can ask them as well. So feel free to unmute or put something in the chat.
You mentioned, sorry, just there's like a face-off between like tidyverse and kind of datatable. Like, what was like the main kind of like, you know, I know you talk about the syntax, but like, what like was there any kind of like result, like conclusion to that kind of argument, or was there?
I would say no. I mean, and it's they also work together a lot. Huh? It's there's not an open battle or something, but it's yeah. It seems it really comes down to preference and to what extent you think fast performance is important. It's probably true that most people, maybe 95% of the people, work with file sizes that for which speed is not that relevant. So I think it comes down to that, but it's yeah. I don't know. Some people take it for a fact that tidyverse is like clearer to read, but then other people do not agree. And it's easy to get for some people to get very emotional about it, but I don't think there was a very strong conclusion to the discussion. No. Okay, with that, I will go to the script. So I shared a GitHub link with you so you can find the script there as well. So if you've cloned it, you can just open the script in R Studio. Yeah, I will leave it up to you. I will walk through it and describe a bit what I'm doing. If you want to code along and make some notes in the file, go ahead. Or otherwise, you can just watch. We'll give you some time to open the file if you want. Okay, and with that we can start. So at the start, I'm setting our time zone to UTC. That might avoid some issues with local settings, but there's actually, well, actually it's no longer an advantage, but if you read date times with datatable in UTC, which is now the default, but it used not to be, it's actually faster. So that's something that's maybe good to realize. And then I'm setting the working directory to the location of the R script. If you work in RStudio, this should work for you. If not, you will have to put the path there manually. And I'm setting a seed because I use some random functions. So that way it's reproducible. And then we load our packages. So I assume that you have installed these packages. Actually, datatable has very few dependencies. It actually, datatable only relies on itself almost. So you don't need to install other packages to use datatable. I'm using some others mainly in this script to demonstrate some things. But if you want to use datatable for yourself, you do not need any of these others. And then we're off to creating our first data table. It works very similar to data frame. Usually you could make a data frame with the data.frame function. You can create a data table with the data.table function as we do here. And this creates a DT small, I've called it, which is one of the files that I will use for a lot of the examples. So we just have a column with letter, AA, BB, CC, rank, and a random number. And if we look at the...
Sorry, you
yes?
just had a question there in the chat. what about why is it better to work with UTC?
It's so for data table it can read as POSIX and it is faster if it's in UTC. In general, so one of the packages that's often used is lubridate, which takes UTC as the default, but your base R functions have your local time as a default. So I have had once that I was trying to find a line where it was 9 o'clock and it returned the line was 7 o'clock. It's tends to be advised by some people to just work in UTC unless you really want to use the functionality of your local time zone. But you can work with local time zone as well.
So, just a quick question on that. Would you recommend in terms of like storing your data and stuff in UTC, or rather reading it in and converting to UTC?
When storing data, I would usually just print it. So then it doesn't really matter. If you would store it like in R, I don't know. It all comes down to do you want R, for example, to recognize that if you switch from summer to winter time, that it's a continuous data set and that there is not a double line. If that's a functionality that you would like to use, then just go for it. Also depends if you're using a global analysis or if it's all local. Yeah, but within R, I prefer to work with UTC, but that's not a data table thing, I would say. So when we create this data table, or when you read a data table and you look at the class, you will see that it's both data table and data frame. So this is what I meant with its extension to the data frame. If you use the table from thaidiverse, it's I think the same thing. And we will also quickly make a data frame out of it, which is called the F small. That's just the data frame version of our data table. Usually you will actually read data table from file, from which we will use the fread function in data table. In the folder on GitHub, there's a data folder, and there's this file, which is daily water temperature profiles from Lake Erken in Sweden, from a publication by Simone Moras and colleagues. I will also use this for some demonstrations. So if we look at the top rows, this is something that I meant with reading in UTC. That means that it's already POSIX-CT format, which is the format that you would usually use for daytime. We also see that there are not yet column headers, and that the depth is in negative below surface. So that's something I just prefer to set some column headers and make the depth positive. For both these things, we will later learn a better way of doing it, or more data table-y way. But for now, this will work. A lot of things will, like doing what you were used to with data frames, will just work because it's still a data frame. So about the fread function, it reads any delimiter file, and it's very fast. It's one of the fastest ways of reading tables. Maybe the fastest. It also reads URLs, and I think you can even put commands to command prompt or terminal to unpack a zip file or something. I haven't really used that. And it's already in POSIX-CT because we already put our time zone in UTC, or if you put it as an argument. If not, it's still possible, but it will be read as a character. So then you would have to convert it yourself to your own time zone, which is what would happen in read CSV as well. And then we go to the first part of the data table trinity, I, J, by. This would be subsetting I, and this works very similar to data frames. It's for if you want the rows where rank is less than 10, you would just put it like this. The difference with data frame is that you do not need to put this DT small $ there before rank. It would still work, but it's not needed. And you do not need a comma at the end. You can again put it there, but it's optional. So far it's still pretty similar to data frames. And you can also select the row 3 to 5 like this. Works similar. So now we go to J, which can be quite similar to data frame. For example, to select the first and the second column, you do it like this, the first to the second column. This does something similar. You put the column names in a vector like that, which also returns a data table. You can put a list there. And then now something that is a small difference between data frame and data table. If you put a letter between quotation marks, it's similar to the vector, right? So as you would expect, you get a data table back. But in a data frame, in the F small, if you do this, you get a vector back. So this is a small difference between the two file formats. You can get the same thing from data table. If you would do a list, single list, you still get a data table. If you would just put the column name without quotation marks, you do get a vector. So that's the way to make it similar to data frame again. Or you could type this if you prefer. So this is something to, there's a lot of similarity between data table and data frame, but just converting your data frame to data table and still expecting everything to work might go wrong because of this reason mainly. But the power of J is that we can also do calculations within it. So you can also calculate the mean of the number column, for example, like this. And we can do that with multiple columns or multiple calculations by putting them in a list. And we say mu is mean of number and sigma is the standard deviation of number. And then we get a data table back that looks like that. Because you would use the list function a lot in data table, they made an alternative for it that works within data tables, which is dot and then brackets. So it does exactly the same thing. This is something you might see and might be a bit confusing when you see it for the first time, but it's just the list function. And of course, you can combine it with I. So if you want to calculate the mean of the number column for the rows that have rank less than 10, you just get this, which is slightly different from the mu here because we only use certain rows. And then we go to the last part of what you would usually do with data frames, which is the grouping, the by argument, which you will always use together with J. What do you want to do per group? So for example, we want the minimum rank for each letter in DT small, which would return this. And you can also use multiple groups, or you can use conditions. So if we go to our DT lake data table, we want to calculate the mean temperature for every date, and we want to split it sort of between less than 10 meters depth and more than 10 meters depth, which would get sort of true if it's less than 10 meters depth. Then on this date, this is the average temperature. And if it's more than 10 meters depth, it's this. I'm not sure if I would advise to do it like this, but it's just to show that it's a possibility to have multiple things and conditions there. So something that if you want to calculate surface temperature, for example, you might say DT lake depth is less or equal to 1 meter. We want to have the mean temperature, and we want to do this for every year. Year is another function that's provided by data table. In which case the answer looks like this. For every year, we have the average temperature. Maybe we also want it per month, so we add months to this function call. You can do that, of course, at once, but I just show that sort of how you build up the logic, which means that for every year and every month, we have our average surface temperature. And lastly, now up to now, this column was called V1. We can already set the column name here as well, which will make it look like this. So essentially in one call to data table, you can do sort of limnology calculation in a quite clearly readable way and standardized format. And yeah, this is,
sorry.
Yeah, go ahead.
Quick, what happens when you print a data table to the console?
When you
Because I'm just
print.
like ANS. Sorry.
So now I'm just putting this ANS as a new data table. I'm storing it as a new data table. I think, would this work? No. Anyways, if you do not, so either you can now print it to the console just by running this, or by not assigning it to a data to a variable. So it's, yeah, I can now access it like this. That's the only reason. So then there's something else that you will often see in data table code, which is a new special symbol. It's called, that's created by data table, which is .n.
Sorry, yours. Just another question.
Yes.
There, with regards to the last bit, we're from Marcha, and she's asking, can you leave the by statement out, or is it necessary? So I
No,
think
you can. You don't have to put the by statement. Actually, also actually it's all optional. Yeah. If you do not have a by statement, it will not be grouped. If you do not have an I statement, it will use all rows. And J, yeah, if you do not use J, you would just select few rows. Yeah.
Okay, so the third argument within the square brackets automatically goes to the by argument.
Oh, sorry. Okay, you mean if you need to do put this, if put by equals. That's a good question. Actually, I don't know. It always said to be. No, it's not. It's not necessary. In all the data table code that I've seen, it happens. I guess it's a bit for readability. It's actually so normal that I never tried it, but yeah, it's not necessary. There are some other arguments you can give in to the data table, which we will see later. So it can be useful to specify what the argument is about. So to that, we have .n, which is, it's actually quite simple. It's just a replacement to be calling n row all the time. Because this is something you might want to do a lot. For example, in this call, we want to know how many rows do we have for each letter. We want to group by letter, and we want to get the number of rows. Otherwise, you'd have to do n row and then some random column. .n is shorter, it's quite readable. That's the only function it has. And you can also put the condition in by, so this would return how many rows do we have with a number bigger than 0. Which is 6 and 10 are smaller. And because it's the number of rows of your data column, if you use it in I, you would just get the last entry of your data table. And now we go to something that's quite important for data table, because updating by reference is one of the things that makes data table fast. And for this, you use the walrus operator, which we see over here. So if you look at it and then you tilt your head about 90 degrees to the left, you see why they call it the walrus operator. And it is used to add new columns, remove columns, or update columns, essentially. So if we have dt small, we are now going to add new call to our data table, which is done like this. And now there's one thing that's maybe a bit annoying. Our studio hasn't really updated. You still see here, we have dt small with 3 columns, but ncall does return 4. And if we look at it, we see that we do have this new column. So it's something to realize that because you do it by reference, you don't make a hard copy, which is the part that makes it faster, makes it more memory efficient. But it means that our studio sort of misses out on it. So that's something that you should be aware of. But otherwise, this is a very fast way and concise way of adding new columns. And you can also modify a column by reference. Here we do it including I. So for ranks that are less or equal than 3, we want to add 5 to our new column. And if we look at our data table, we see that 5 has been added to these rows only. And if you want to remove a column by reference, you say semicolon or colon equal no, and then it's gone. So important part for updating by reference, that means that you do not put dt equal or another assignment operator in front of it. That is not necessary. That will actually never be necessary if you update by reference. If you want to modify or remove multiple columns at once, you can use this format. This is not a quotation mark, it's the other one. I don't know how it's called. Just put it in front as if it's a function, essentially. So now we have added 2 new columns, and this way we remove them again. So this is something you would also use a lot when using data tables. See, there's a new something in chat. Is there another question?
Oh yeah, sorry. From Shimilas. Do we have the option to add the new column to the left, right, or in the middle?
I think this would just add it to the right, but there is actually that's something we'll see now. There is the set call order function that would by reference set a new order. So, but I think it would be a different operation. Yeah, I don't think there's a way to. Yeah. Okay, so then, and that's actually something I just showed. There is another way of updating by reference, a bit more in general, which are these set functions. So there are multiple functions within data table that start with set, and this means that it is by reference. So that means no dt equals or no dt assign in front of it. Set call order is one, which I actually hadn't included in the script, so it's good that the question was there. But the normal set order would do it on rows. So if we do this, minus for reverse ordering, we order our data table reverse by rank. So if we look at it, it's now ordered from 16 to 1 instead of from 1 to 16, which happens by reference, which is of course rather inconsequential here. But first of all, you don't have to assign memory to get a new one, and on large data sets, this might actually save time. So we set it back. Another way is to set the change column names. So instead, first we used all lowercase letters. Now we will make the first one a capital by set names. So now it's using capital letters. And one that you might use quite often, sometimes maybe you're reading an Excel file, and at least data table does not read Excel files. So you would read it as a data frame first, and then you might want to convert it. You can use the setDT function. So if we are looking at our df small, which was a data frame, we do setDT. Now it's a data table. We can do setDF, and now it's a data frame, all without assigning memory, and it's very quick. And the one that you might use actually least often is the set function itself, which is used to change a single value in a data table. Which is mostly used inside for loops. So you would have to, you are replacing a single value inside a for loop multiple times, which means that if you call the walrus operator every time, there is some overhead. So this is slightly different. This is still not a recommended thing to do as in normal R. This is you should always try to vectorize things because it's a lot faster. But I think we all have had situations where it can't really be avoided. In which case you can use the set function. So here we set the value in the 3rd column and in the 8th row to 100, which you can see that now the value for number in the 8th row is set to 100. This would do exactly the same thing, just in a for loop. It's slightly faster to do it with the set function. And that's pretty much it what I wanted to do before the break. I will close off by actually writing data table. We saw how to read it, how to handle data, and now we see how to write it. With the fWrite function, which stands for fast write. Once again, it's faster than the normal write function. You just put it, and it works very similar to write CSV. You put the thing you want to write here. We just write the year 2000. for the lake data set, and you just put the path where you want to write it to. And if you want, you can add a separator, otherwise it will use commas. So we do it like that. But there is one small thing you should know. If we then look at our data, you will see that this is the format of our time, which is ISO format. That's sort of the international standard, which is all very nice, but it's not super readable. So if this is something you do not want, you'd have to add this argument date time as write CSV, which will give it similar behavior to write CSV. Slightly slower, but does get the time format right. And that's about it, what I wanted to do before the break. Yeah, I would say this is really what you will use 80 to 90% of the time. You already know now. If you sort of understand what was done so far, you could already start using datatable. After the break, I would show a bit more advanced functionality. But yeah, I mean, it won't get super advanced, but that would sort of cover the rest up to 99%, I hope. So yeah, I would say a small 10-minute break so that we are back 5 before the hour, just to stretch the legs and maybe drink something. If you have questions, you're of course welcome to ask them as well, if they are relevant for like the wider audience. I will just repeat them when we start again. So yeah, don't hesitate to yeah, grab something to drink or something. So yeah, see you back then.
Just one quick thing before if you just take a break. It'd be nice to take a photo just to kind of show that we are here. So if people wouldn't mind switching on their cameras, and I'll just grab a quick screenshot just to and get the okay, yeah. It's great to see so many faces as well. Okay. Yeah, no worries if your camera's not working. I'll just grab a quick screenshot. So 3, 2, oh, 3, 2, 1, cheers. Or cheese. Cheers. Might be a bit early in the day for cheers, maybe. For me anyway. Okay, cool. I have that saved. So yeah, if you want to take a quick 5-minute break or 10-minute break, sorry, we'll be back at the hour mark, is that right?
I would, yeah, a bit before 5 to the hour, maybe.
Okay. Thank you.
Okay, give everybody 1 more minute to come back. Let me start sharing my screen.
Jorrit, oh,
Yes.
I have just a quick question. I was just wondering if you could explain a bit more about the walrus operator. Is it just for like making new columns, or what's the?
Yeah, it's essentially making new columns, removing columns, or updating columns, changing columns. So you would always use it in J, yeah, as to change columns. Okay, I wanted to show quickly. So I had a bit in mind that this script could function as a cheat sheet if you're using it and then you want to go back, like how do I do things? In RStudio, there is this, you can press Alt plus O and then it will collapse the script into all the headings. So I tried to use these headings so that you could sort of look up like, okay, how did I update by reference again if there are multiple column, so that you just click there and then you see, okay, it was like that. So that's something for you to be aware of if you want to use the script like that. That's possible. And then Shift Alt plus O would uncollapse everything. So where we left off, that was here. Yeah, so this would be a bit more advanced use of data table. I mostly put it there to think like if you already thought the first half was like a lot and you just need to work a bit with that, yeah, don't worry. With that part, you can do really most of the things you need. This is just some of the things you might. I still don't go into like the very specialized use of data table. I also don't use it myself, but these are things that might still come in handy for you. The first one, which is actually might not be like advanced use, but I put it there because you don't really need to know it, because the data table functions for switching between long and wide formats, also known as reshaping or pivoting, they are actually the same as in base R. So they are called melt and decast. So you can go from, so what we will do here now, if you're familiar with R Lake Analyzer, this requires data to be the left column to be dates, and then to the right as if it were all the depths. So now we have it in long formats, which looks like this. No, this is the wrong one. This one, we have it in long formats, and by calling decast like this, we put it in white, and now we can also change the titles. So in just 2 calls, this would be a data set that you could put into our Lake Analyzer. It's actually the same name as base R, but it is faster for data tables. And the same for going back to long format, you would use the melt function. And then because one of the columns is in vectors, you need to convert that, which would also be with the regular melt function. And now we would have dt lake long, which is the same data in long format, although now with NAs. So just so you're aware that these functions exist. And then we go to something that is indeed maybe a bit more complex, which is .sd. .sd is another special symbol that's used by datatable, and its main use is to use a function on multiple columns, SD standing for subset of data. Something to realize, .sd refers to all columns in the data table itself, excluding those mentioned in the by column. And we'll see later why that might be handy. That's the default, and otherwise you can add the .sd calls argument. So let's have a look at how that works. This call over here actually does nothing special. It just say I want to have all the columns of my data table. So it would, yeah, this doesn't really do anything. But if you add the .sd calls argument, you can select which columns you want to select, which is still at the first half we learned already a more concise way of doing this. But its use is mainly to avoid this. So you don't want, if we have this wide lake data table with a lot of columns, if we want to test if all these columns are numeric, we do not want to have the type is numeric for all the 38 columns. So what you can do then is to put .sd in a lapply function and apply the is numeric function to it, which will do essentially the same thing for all the columns. And it's really this use. So if you have a function that you want to apply to multiple columns, if you're familiar with the lapply function, you can put really any function there. You can even write it in the place. And that's why you would use the .sd, option, special character. You can put an argument in .sd calls to just do it on a few, if that's what you need. And something that you might want to know is that .sd calls can also be a condition. So if you want to calculate the mean, but with NARM is true, you do not want to do this on columns that are not numeric. So you could do something like this, and then you would get this data table back as it were. Why is it handy that the column in the by argument is not included? Well, if you're grouping by columns, you do not need to, for example, take the mean of that group because they will all be the same. And especially in the case of letter, it's also a character, so you can't do that. So by doing this call, you just calculate the mean for every letter. This is something you might want to do.
Just a quick
yes.
question. Sorry, I'm probably jumping into.
No, that's very good. Very good.
The use of lapply. So it's so kind of is the base, like, does data table always expect it to be sort of like a list? Is that kind of why lapply is there?
Yes. So that's why you also use the list function. If there is a list in J, it will mean that it will always return a data table, essentially. That's a bit the logic behind it. So that will mean that the format of what you get back will always be a data table. That's why also the small letter, actually, no, it's with a capital, I think, will give you a vector, but when you make it a list, it will become a data table. It will return a data table. That's why it's lapply and not one of the others. Yeah, good question. If .sd seems a bit too complex, just realize that this does exactly the same thing. This will give you exactly the same outcome that we got here. But of course, if you have a lot of columns, this would become a lot of typing. So that's what you might want to avoid. So next topic is something that's not really it's more of a caveat that you maybe should be aware of when using data table. This does not happen often, but it can leave you really confused if you do not know what's happening. Because data tables work with referencing, you update by reference, you do not make a copy. It can mean that you will get two references to the same object, which is called aliasing. So as a demonstration, if we take row 2 to 4 for number, we get these three numbers. This is in dt small. Then we say, well, we just want to make a copy of dt small. We call it dt alias. And then in dt alias, we update by reference the number column, which is multiplied by 2. Then we see that in dt small, it has also been multiplied by 2, which is something you will almost never want to do. So that's something that you might be surprised by. And this can also happen in functions. Here it has the advantage that you could write your own set functions, I guess, but still usually you do not want to use it. So here I made a function to calculate the largest difference in a certain column, like the largest step from one row to the next. So we put in a data table, we give a column name, and maybe within this function you think, okay, it's a good idea to make a temporary column by reference because it's faster. Then we calculate diff and then we get the max back. If you do that and you apply it to dt small, you get the right answer. This would be because we set one of these values to 100, remember, so this would be the right answer. But then if we look at dt small, we see that this diff column has been added, which is not what would happen if we do this in a data frame. So, this is something we usually do not want. Fortunately, the solution is quite easy. You just have to use the copy function. If you want to make a copy that is not an alias, use the copy function like this. Then if we have these 4 numbers, we make dt not alias, we update the reference there, and then they are still the same numbers in dt small. And you can also use this in the function. Because now you are making a hard copy, that's then again the old use of R with memory, so that would then cost some memory again. But that's something you need if you do not want this aliasing to happen. So now we can apply our function and leave dt small as we want it.
Okay, so the alias thing happens when you just assign it, use the assignment operator.
Yes.
So you need to use copy if you don't want to use it. Okay.
Exactly. Yeah. It's a personal choice that I use the equal symbol. If you use this, same thing.
Okay.
And then there is another special symbol. I know I'm introducing a lot of them. I think this is the last one I will use, and this is pretty much all you will ever use in terms of extra symbols, which is .i, which is all about finding the indices. So up to now we got maybe the rows, certain rows, and then we get the value in another column. .i returns the indices. So in this call, which might look a bit confusing, in dt small, we want the indices where the letter equals b, so that those are indices 5, 6, 7, and 8. Sometimes this can be handy. Actually, in the exercises at the end, I have one place where you can use this. But this you could use with the which function that's in base R, which you might know already. But the big advantage of .i comes when you are grouping, because it will return the indices in the original data table. So here we want to get the index of the maximum temperature for each year. And then if we run it, you see it's still ascending. So it still gives the index in dt lake for each year where you find the maximum temperature. It might not appear very useful, but in the exercises we will use it. We will calculate onset of stratification, and you might want to know if the measurements before your onset is an NA, for example. So then you can get the index -1, check if it's NA, and if it's NA, okay, we actually don't know the onset. That would be one use. I see something in the chat. Super useful. Yeah, I also, it's like I didn't realize it at the start, but some point it really saved me. So there,
Just another question there, sorry, yours.
yes.
But are there any interference or conflicts between the functions of datatable and other packages?
Yes, it could be. Most of the, especially current packages will just work, but not all. For example, our like analyzer, I forgot what it was, but essentially, if it's with table, if it's something doesn't work with table, or there are a few other alternatives, it might also not work with data table. But because it's still a data frame, almost everything will work. But yeah, in a few cases, not. Yeah, that is true.
Yeah, because I was thinking when like you have, because dcast you say and melt, those two functions are in data, but they're also in the reshape and the reshape2 package. So
Yeah,
would they, yeah, they would obviously be conflicts, or they would
yeah.
be end up
So
being masked.
yeah, that would happen if you. Well, what's that again? The one that you import first takes precedence. So then you would have to call it like data.table dcast. And actually, they have a what's it called? Anyways, the dcast.datatable will call the one you need. So if you're afraid that it will interfere with reshape, you can use dcast.datatable. Yeah, good question. Next point is if you want to bind data tables together or data frames. In base R, you would use rbind, which I think you can only do two. Data table offers something that's also very handy, I think, rbind list. So now we have a DT1 and a DT2 and a DT3. And in DT3, we have an extra column. Might be, think about you have 3 years of data, and in the last year they suddenly decided to measure one extra thing. In base R, this could be quite problematic if you want to merge them, but with rbind list, you can just put a list of all the data tables that you want to merge and add fill is true, which will fill NAs in the place where this wasn't measured, and it will still include the values where it was. So this is some extra function that data table offers. Merging, which is, yeah, so then you have two data tables with one similar column, and then you want to merge values where they match, which you can. So we make a DT4 where we make a new number column, and then DT merge, we can use the merge function. Once again, it's called the same as in base R, but it's faster on data tables. So DT merged will now look like this, where we have we merged on rank, so the rank is common, and we have a letter, a number, and letter Y for the one on the left, so to speak. If people in data table talk about merges, they often use a different syntax, which I put here on the bottom. This is an inner merge, which means that any things that do not overlap are fallen out. In this function, you can use the all arguments. You have all X to keep left, all Y to keep right. That's the same as in base R. Sometimes they will use this format. It's something I do not prefer, but yeah, if you like that, you can do that as well. I included a link here for more information about merges and maybe some more complex more merges or joins that you might need. The next point is if you want to use a variable name instead of a column name. I think this is also something that, I don't know, it doesn't sound super useful, but I guess everybody does it from time to time, because this gives an error. If you say my call is letter, and then I want to select my call, then it will look for a column named my call, which is not there. Something that is also quite good in data table, error messages tend to be quite long, but they tend to be quite good. They point you to the right direction, which here they already suggest the solution. You can put 2 dots in front of the name, and then it will look, and in this case, letter. And the logic behind this, if you are familiar with command prompt or terminal, if you type 2 dots, you sort of go up one environment for one directory. And the idea is that instead of looking in the data table environment, you look in the R environment. So then it will check here, what is my call? Oh, it's letter, and then it will look it up. Before this was introduced, and you can still use it, you can also put with equals false at the end. That's an extra argument you could add, and then it will also work. So then you do not need the double dot. And you can use this with multiple columns, double dot my calls, and you will get what you would expect. When you define new columns using the walrus operator, for example, it works slightly different. If you would do this double dot new call, it doesn't give an error, but you are adding a double dot new call column to your data, which is, it's good that the option is there. Maybe you want a column name to start with 2 dots. But this is not what we want in this case. But if you put brackets around it, it will do it as it's intended. Then it will be called new underscore column. And these are most of the things I wanted to mention in this workshop. I will now mention a few things that I will just glance over very quickly, just so you're aware that they exist. One is keys. You can pre-sort one or multiple columns. Might just be one actually, which is good if you do repeated searches or joins on this column. I heard once the analogy where it's instead of just having a long list of names, you sort of pre-sort these names in a box with an A and a box with a B. So like a human brain would also find the information faster. It works a bit similar. So if you do a lot of repeated searches on this column, it can also lead to speed up. You do this with set key. But yeah, I mean, I never really had to use it. I found this quote on the internet by Professor Grant McDermott from the University of Oregon, who has given a very good introduction to data table as well. He said, use keys if you're really serious about performance. It doesn't seem something that's super relevant. Then there's chaining. This is data tables alternative to pipes, you could say. You can still use pipes with data table though. You can put just double brackets after existing double brackets. So then it will just do first this and then pass the results into the next one as you would use a pipe. So in this case, first we multiply the number column and then we round it to two digits. Yeah, I leave it to you, up to you if you like this, because you update by reference already. I don't think the speed up of doing this is really there. Maybe I'm wrong. So you could also just put it on the next line as the next operation, which I think is a bit more readable, but it might sometimes be handy. Then there are several functions that data table provides. There are actually quite a lot that are just fast alternatives for base R operations. So base R has the if else function. Then data table has if else, fast if else, which just does the same things but faster. F case is a nested if else, which is similar to dplyer's case when. Like is like grepl, but faster if you used an I, and there are others. So here's a quick example. We make a list from 1 to 10. If we want to see what are even numbers or odd numbers, you could use it like this. It's also, I would think this is more of an advanced feature because it might speed up your code, but it's more realistic that your bottleneck is something else than this, I think. Then I wanted to demonstrate how you can use it with R-Lake Analyzer. This is something I discovered a bit recently in a project that actually can speed up R-Lake Analyzer a little bit, not by changing any of the code, but by calling it through data table. For this, we need the hypsograph. We want to calculate smithability. So we need a hypsograph. It's also in the data folder that I've included. And then instead of using the TS, if you're familiar with it, it's a time series function of R-Lake Analyzer. You need this wide format, which is something not everybody likes. But this way you can also use it in long format. And you can call smithability function in J calculated by date. And I found that this was actually, I forgot, 10-20% faster than the TS function, at least for a big data set I used. So might be something that's interesting for you. And then you need to set the names to be data transmissibility, and then you just get a time series that you would get from otherwise the TS transmissibility function. And then you can, for example, plot this with ggplot. Datatable does not provide any plotting functions, so most people, I think, just use ggplot or base rplot, and then you get the result like this. And that brought us to the end. I think, yeah, we're sort of on the timeline that I had imagined for it, so that's good. At the end, I provided some links for further reading if you want to. So this is the website of Datatable itself with a lot of information, the latest updates, etc. They have some vignettes, especially the first two are really good, although I think in this workshop we covered roughly the same material. If you want to know how fast Datatable is, here's a link to this benchmark site that I showed before. As a reminder, if you do like the high performance, but you want to keep thaidiverse syntax, check out the dtplier package, might be good. If things are not going fast enough for you, often it pays to just type in on a search engine, can I do this faster? And there's this fast time package for fast conversion to POSIX. There's repeated matching for fast match, and there are probably a lot more. I don't really know. If you're really serious about this, you can use the RCPP package to write code in C++ and then use it in R. That does require some effort. I do think that's also from my own experience. It's very easy to spend 3 hours on making your script 2 seconds faster and then using that script 5 times. Yeah, so that's maybe just a small warning with that. Because Datatable works on, well, Datatable speeds up your workflow most when you work with large data. I thought I also mentioned something about storage. If you like data storage, if that becomes a problem, there's probably a lot more about this. I'm not an expert on that or anything, but the arrow package might allow you to save a table in Feather or in Parquet format. Parquet can be opened by a large variety of software, and when I did it on a large data set, my file size got like 5 times smaller. So that's something I was enthusiastic about as well. And if you mainly work in Python, well, we saw that this Polars package is really fast as well. But there's also a Python alternative for Datatable, PyDatatable. So that might be a link you might want to explore as well. And with that, yeah, I would like to thank you a lot for your attention, and I hope it was useful. This script you might be able to use sort of as a cheat sheet, but you can contact me either by email or on the GLE on Slack if you have any questions regarding Datatable. I'm always very happy to take time to help you out with that. So yeah, don't hesitate to ask. With that, I would like to just open the floor for questions. I have put exercises at the end. I hadn't really planned on how to go through that. I thought I'd just leave it to you. I have put the answers also on GitHub. There is this answers to exercises folder, and it has this script which has at least my answers to it. There are probably multiple ways to do some of them. At the start, there are 4 exercises. We want the standard R data sets, and then at the end, you would calculate onset of stratification at some point with quite a lot of assumptions, like we need to have at least 10 days. We don't want NAs before our measurement, etc. And I think one of the key messages from the exercises is, if you look at the answers, is you can solve complex problems with Datatable in just a few function calls, and it's, at least in my opinion, it's still quite readable. So that would be the main message, I guess. So thanks a lot. And yeah, if there are any questions, please go ahead. I see there are some things in chat. Oh, thank you.
Thank you very much, Jorrit. This was a very insightful workshop and really great demonstration of what this package can do. So thank you very much for that. There's a question about accessing the recording. The recording will be posted on the Gleon Limnoseries channel, and that will be shared with all participants after we save that. So yeah, I'm going to stop recording now, but again, like Jorrit said, the floor is open if anyone has any questions.